So today, what we're going to talk about is a different special right triangle. We've already talked about the 45, 45, 90 degree triangle. Now today, we're going to talk about a 30, 60, 90 degree triangle. Now, these are special right triangles, remember, because we can use ratios no matter how small the triangle is or how big the triangle is. We can always use these ratios to find missing side lengths. Okay, so let's go take a look at our notes. So just guys, as a review, remember that an altitude is the perpendicular segment that goes from the vertex and is perpendicular to the opposite side of the triangle. Now, the altitude is the height of the triangle. Remember, because I said that the height and the base will always be perpendicular. Okay, so that will help you. Okay, now in a 30, 60, 90 degree triangle, there's some different ratios than what we talked about with the 45, 45, 90. Okay, so we still are going to go across the triangle, but I want you guys to notice the ratios are going to be different. Okay, the ratio of x is always on the shortest leg. Guys, it is always going to be across from the 30-degree angle, opposite of the 30-degree angle. And the ratio of x square root 3 is always on the longest leg, which is across from the 60-degree angle. And then the 2x ratio is always going to be the hypotenuse, which is across from the 90-degree angle. Okay, so having said that, you guys see, look, we got some different ratios. We have some different angle measurements, but this is always true for every 30, 60, 90 degree triangle in the world. Okay, now something that I want to point out. Do you guys remember for a 45, 45, 90, if we took a square and the diagonal cut it into two congruent 45, 45, 90 triangles? Well, guys, now in an equilateral triangle, guys, if you guys notice right here, the equilateral triangle, the altitude cuts this equilateral triangle into two congruent 30, 60, 90 degree triangles. Okay, so these shapes, man, I'm telling you, man, there's triangles everywhere in every shape that we have. Okay, all right, and just as a reminder, ladies and gents, always, 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 okay, if you want to get credit for your assignment, label your triangles and put a box around the ratios. Okay, all right, you guys ready to dive in? Let's get this thing going. All right, let's go down and, hey, you know what, guys? I'm going to do number 4 with you today. So go down and do number 4. Okay, so we're going to start off kind of easing in. Okay, now what we're going to do, just like we did with the 45, 45, 90s, the very first thing you're going to do is you're going to label your ratios on the triangle and put a box around each ratio. Then you're going to use the properties of special right triangles to solve for y and z. Hey, guys, look right here. Leave your answers in reduced radical form for numbers 3 through 6. So remember, that means no decimals, right? We'll be looking for that. No decimals. Okay, all right, so number 4, let's go take a look. Very first thing, we are going to label the triangles with our ratios. So across from the 30-degree angle, okay, opposite of the 30-degree angle is our ratio of x, and I put a box around it. Across from the 60-degree angle, well, wait a minute, the 60-degree angle is not labeled. Well, ladies and gents, if you have the 30 and you have the 90, then the one that's left over, hey, that's your 60 degrees, isn't it? Okay, so 60-degree angle is right there. Okay, across from the 60-degree angle, guys, that's our ratio of x square root 3, and we put a box around it. And then our hypotenuse opposite the 90-degree angle has the ratio of 2x. Okay, we are going to start with what we know. Hey, guys, we know this side length over here. We know that 5 and x square root 3. So that's where we're going to start. Okay, so I'm going to zoom in here and we're going to show some work. Remember, 5 and x square root 3 represent the same side. So that means that 5 equals x square root 3. Okay, now we're going to use those rules of radicals and we're going to solve. We're going to solve for x. We're going to get x all by itself. Okay, so we end up with 5 square root 3 equals x. Remember, we have to rationalize the denominator. So we are going to multiply both the bottom and the top by the square root of 3, and we end up getting 5 square root 3 over 3 equals x. Hey guys, remember, this is the x that is in the ratio, isn't it? Okay, this is the x that's in the ratio. So let's go back and look at our ratio over here. So, and I'm going to circle it. This x right here is the same x that is in each of these ratios right here. Okay, so in this first box, if we're solving for y, okay, and I'll do it in red. If we're solving for y, well, y equals 2x. Hey guys, here's your x. You're going to go and plug it in. Okay, so you have y equals 2 times 5 square root 3 over 3. Remember, numerator to numerator, denominator to denominator, we could put that over 1. Remember, whole number to whole number, radical to radical. So y is going to end up equaling, okay, and I'll write it out here. So 2 times 5, so 10 square root 3 over 3. Okay, can I simplify that anymore? Nope. If I simplify 10 over 3, it's going to give me a decimal. I don't want that. So, ladies and gents, your final answer for y is 10 square root 3 over 3. That's your value for y. Okay? All right, so do you guys see how I did? I solved for x in the ratio, and then I went and I plugged it in. Okay, so let's do this next one. Let's solve for z. We're going to do it in purple right here. So z is right here. Hey guys, z equals x, doesn't it? Because those two are the same. Well, if I take this x and I plug it in, well, if z equals x, then doesn't z equal 5 square root 3 over 3? Yes. Okay. Now, see, that wasn't too bad, was it? Okay, so z is 5 square root 3 over 3. Okay. All right, so look at what I did here. Recap. Label your triangles, put a box around the ratios. Second thing, solve for x in the ratio by starting with what you know. Okay, then go back and plug x in to each of the ratios. Okay, all right, so let's go and take a look at another one. Guys, I'm going to help you get set up on number 7. So let's go look at number 7. Alrighty, down here at number 7. Okay, read the given information. It says the side length of equilateral triangle JKL is 5 centimeters. Okay, now we're going to use a ruler. We're going to accurately draw and label the triangle. So let's see. What does that look like? Well, ladies and gents, we're going to draw an equilateral triangle. And if it's equilateral, that means that all 3 side lengths are the same, doesn't it? Okay, so when you draw it, you're also going to label it. Okay, so I have, let me go back here. I'm also going to label it. I have J, K, and L. Okay, so that's what it looks like. Notice then the next thing says, draw the altitude from vertex K. Refresher, altitude starts from a vertex and is perpendicular to the opposite side. Okay, so we're going to draw the altitude from K and is perpendicular to the other side. Okay, so that means that it's perpendicular on this side, perpendicular on that side. Okay, now, you guys remember, I said in an equilateral triangle, whenever we draw in the altitude, what kind of triangles does that create again? Okay, so hopefully you remembered that I said that it creates 2 30, 60, 90 triangles. And by the way, this is on the front page, your notes, isn't it? Okay, so right here, now, we're going to label the ratios on the triangles created by the altitude, and we're going to put a box around each of the ratios. And then we're going to use the properties of the 30, 60, 90 triangle to solve for the length of the altitude. All right, so I'm going to help you guys get set up here. There is something that it told us in the given information, and I want you guys to go back and read it. There is something in the given information that I did not label on my triangle. Well, go look. What did I forget to label? Hopefully you guys went back and you said, hey, Miss Smith, it told us that the side length is 5 centimeters. Oh, And remember, if right here, well, that's going to give us a decimal. We want to leave our answers in reduced radical form. I'm just thinking out loud. So we're just going to start with the 5 centimeters. Okay, we're going to label our ratios and put a box around them. Okay, across from the 30 degrees is our x. So that means that both these sides down here would be x because they're both across from the 30 degrees. Across from the 60 degree, hey, that's our altitude. That is x square root 3, and I'm going to put a box around it. And then both of the hypotenuse, okay, are 2x. That's the ratio. All right, so, what should I do next? Well, let's see. What do you guys think? What do you guys think? You choose. What do you guys think our next step should be in order to solve for the length of the altitude? All right, so hopefully, ladies and gents, you guys have been paying attention. I've said this multiple times here. First thing you do is draw and label your picture and put a box around the ratios. Second thing, solve for x starting with what you know. Okay, hey guys, we know this side length. Okay, so we know that 2x equals 5. So to solve for x, I'm going to divide through by 2, right? So now my x equals 5 over 2. Okay, we've got this far. Now what should we do? What's our next step? All right, hopefully you guys said, hey, Miss Smith, the next step is that we're going to plug in the x to the ratios. Now, we don't necessarily need to plug it into everything because what it's asking for is the length of the altitude. Hey, ladies and gentlemen, that's this right here. We're trying to find the length of the altitude. So we want to find what is the length of that. So now we're going to plug x in to right there. Okay, so if x is 5 over 2, and then we have it square root 3. Okay, so we have a number here. Okay, can we simplify this at all? Okay, do we need to rationalize the denominator at all? Okay, so hopefully you guys said, hey, Miss Smith, that's it. That's all we can do. So the height of our altitude is 5 square root 3 over 2, and don't forget your units of centimeters. Okay, and that is the length of the altitude. Look at there. You guys just used, okay, all of the properties of a 30, 60, 90 triangle inside of an equilateral triangle with an altitude. Ta-da! All right. Okay, so you guys are just roaring to do another one, right? Okay, we'll do one more together. Let's go down. Hey, you know what, guys? I'm going to do number 9 with you because it includes both of our special right triangles. All right, I'll see you down there in just a second. All right, you guys ready for a good one? Here we go. Multiple steps, so follow along. Okay, first thing that we're going to do is we're going to label the 45, 45, 90 and 30, 60, 90 ratios on the triangles. We're going to put a box around it. Excuse me, but the thing is, we have to figure out which triangle is which. So guys, if you look right here, can you tell me, is the triangle on the left or the triangle on the right? Which kind of triangle is the 45, 45, 90? The triangle on the left or the triangle on the right? All right, let's see if you were on track. So first of all, guys, do you see that there's 2 congruent angles in this right-hand triangle? Which means if there's 2 congruent angles, then there's 2 congruent sides. So this guy over here to the right is our 45, 45, 90 degree triangle. Okay, so let's label those ratios. Across from the 45 degrees. Hey, what ratio should I put across from the 45 degrees? Okay, and did you say that you should put x across from the 45 degree? Okay, so we're going to put x. Now notice I'm putting x in the right-hand triangle inside because we have these 2 triangles side by side, don't we? Okay, what triangle, or excuse me, what ratio should I put across from the right angle? So what ratio should I put on the 7 square root 2? Okay, so hopefully you guys remembered that the 7 square root 2 is going to have the ratio of x square root 2 in a 45, 45, 90 degree triangle. Okay, now guys, why am I starting with the 45, 45, 90? Well, hey guys, look at this. This is the side length that I know, isn't it? I know that side length, so I'm going to start there. Oh, okay. So remember, the very first thing that we're going to do is we're going to solve for the ratio. Notice I have not labeled anything on my 30, 60, 90 yet. There's a reason for that. Okay, so guys, I'm going to start with what I know. And y is also over here in our 45, 45, 90 degree triangle. Notice right here that we have, and I'm going to write it over here. Okay, we have that x square root 2 equals 7 square root 2. Those two side lengths are equal. So now we're going to solve for x in our ratio. Okay, so I'm going to divide by the square root of 2, divide by the square root of 2. X equals, what do you guys think x is going to equal? Hopefully you said, hey, Miss Smith, those cancel out, so x is going to equal 7. Now, that is the x in the 45, 45, 90 degree triangle. So now if I go back and I plug it in over here, okay, x equals y, so 7 equals y. Okay, and I'm done. Now, I don't have any units on this triangle, so I just say that x is 7. All right, now, if x is 7, then that means, and I'm going to highlight that, that means that this side length right here, this altitude, is 7. Okay, so what does that look like? Well, I'm going to actually put in 7. I'm going to zoom in here, and I'm going to erase this, and I'm going to put in this side length right here, I know is 7. Okay, now, for some of you, you might want to redraw this, the 30, 60, 90. So if I come over here, and I redraw the 30, 60, 90. This side length 7, this is 30 degrees, and here is my z. Okay, now we're going to label what we know with the 30, 60, 90, but ladies and gents, I'm going to label this in a totally different color. I'm going to label this in red. Okay, so what ratio should I put across from the 30-degree angle in this triangle, this 30, 60, 90 triangle? What ratio should I put across from the 30 degrees? Okay, hopefully you said, hey, Ms. Smith, this ratio is x. That is not the same x as these guys over here because it's a different triangle. It's a 45, 45, 90. Okay, it's a different x. Okay, now, hey, what should I put across? What ratio should I put across from the 60-degree angle? All right, hopefully you said, hey, Ms. Smith, across from the 60-degree angle is x square root 3. Okay, and lastly, hey guys, what should I put across from the 90-degree angle in my 30, 60, 90 triangle? What ratio should I put over there? Yeah, I'm still going to label this as 2x. Okay, I'm still going to label all three ratios. Okay, now we got to figure out. We're going to go through this whole spiel again. We need to figure out what is x in the 30, 60, 90 ratio. Because if you guys will notice, right down here, okay, x equals z, doesn't it? So if we can solve for x right here, then we can figure out what z is. Okay, so, guys, we've been practicing this. Now it's your turn. I know that x square root 3 is the same thing as 7 in my 30, 60, 90 triangle. So can you guys please solve it? And I want you guys to tell me just, what do you get for x? How'd you guys do? Okay, notice we're not reducing anymore because it says to leave our answers in reduced radical form, doesn't it? Okay, so x equals 7 square root 3 over 3. Now that means that if we go back over here and we look at our 30, 60, 90 triangle to solve for z, z equals x. Okay, so if z equals x, then that means that z equals, yes, you guessed it, z equals 7 square root 3 over 3. Okay, all right. Now, again, I know that this was a lot of information. This particular problem especially, we had two separate triangles. We have to separate the ratios. So guys, just remember, do one triangle at a time. And then you can use the information from one triangle to help you solve the next. All right, guys, we've done lots with these ratios. You guys are going to finish this assignment in class. And guys, congratulations. You guys have actually worked with both special right triangles and trigonometry. You guys are doing great. Keep up the good work. See you guys later. Adios.